Thank you again, everybody, for joining us for the 2020 Building Solutions HPC Retreat. This next session will feature Jerry Kettler, existing building systems, restarting operation, maintenance, and improvement. Jerry Kettler is the owner and president of Facility Performance Associates, an engineering firm specializing in building commissioning services, sustainability program administration, air quality consulting and testing, and energy modeling. He is a licensed professional engineer in 9 states and has over 48 years of management and professional level experience in the design, construction, testing, commissioning, lead certification, and operation of physical facilities. Jerry's been an active member of ASHRAE since 1977 and served on a number of committees. Jerry, thank you very much for being here. The floor is yours.
Thank you, Bill. Appreciate it. We're going to talk about today, and again, as Bill said, to answer or ask any questions you want, we'll try to deal with them as we go along here. This is about facilities, and it's about the operation of equipment, mainly the mechanical and electrical plumbing equipment. It's not about, in this presentation, it's not about the operation of the building, which would include cleaning and masks and hand washing and the rest of that you've got to do in current circumstances, but it's about the equipment and some hints and things that we've run into, and that basically corresponds to some national guidelines and standards. Next. So one of the things, I guess, to start out with go back to the basics. What are we really trying to do here with making our buildings more comfortable and safer? Well, first you have to figure out, from a system standpoint, what is it supposed to be doing? What's the function of it? And then if it's functioning, is it performing right? Then the next part of it is things change, is what's in that particular area and what the equipment is doing, what is its function as far as what's in that space. Is it a classroom space? Is it an office space? Or whatever? Is it doing a thing correctly? Then, of course, today, more than in the past, but we've been hearing it for quite a while, that health and safety is a very important item. And we'll be touching on that as we go through, and that's one of the main things on this building startup that we're talking about here, to do it safely. And then at the end, we'll give you some hints on tuning that up, and then maybe improving it on the end. Next. What we've done is basically broken the process down. The problem with most or many people have on building improvements is they start at the end without looking at all of the variations and all of the things that you need to do from the beginning. In the beginning, there's planning, figuring out what you're going to do, and we're going to be talking about all of these levels in detail. And then broken it down into 3 levels, level 1, 2, and 3, very obvious. That corresponds to the EPA and the ASHRAE energy process as far as levels of audit in that. And then the second column there on the assessment, and that is based on some national guidelines from ASHRAE and from DOE about the process, assessment, verification, and then implementation. Each one of them has a separate function, and each one of them leads to the next ones. And then what I did is says, okay, there are 3 levels here. Things you got to do, like I call must-do activities, things that you should do, and then after you finish with that, there are things that you might want to do based on budget and timing and all the rest of that. Next. So essential building systems, and these are just 3 of them. I realize that roofs and windows and security and all the rest of those are also essential. But in this case, air conditioning, we're talking about ventilation, comfort, and more so recently, health. Plumbing also has certain functions, water and drainage, and that also has to do with safety and health, which we'll talk about here as we go through it. And then the lighting and electrical part of lighting is just one part of the electrical process. And we're going to be going into a little bit of both of the lighting and the power as we go through it. Next. So on programming, this is a starting point. Part of the problem with testing a building or designing a building is, what's the building supposed to do? What's going to be in it? What is its function? Who's going to be in there? So you need a program, scope, and intent. What are we really trying to do with what we're doing with startup, with maintenance, with all kinds of things, including the new systems? To do that, you create a document called Current Facility Requirements. On a new building, that's called OPR Owner's Project Requirements. Current Facility Requirements is a multi-page document where the building ownership and the operations puts down on a form and in a document, this is what we want the building to do. This is what, and it gets into a lot of detail, which we'll go into a little bit, but exact things that you need it to do are listed there so that everybody can go back and react to that. Now, Current Facility Requirements document is a flexible document. It can be changed, and quite often is. As you find out that the facility or the operation needs to change, if you find out that equipment will or will not do something, you can go back and change the facility requirements. But CFR is basically a base document that everybody reacts to. Then when you're doing particularly on either new or existing buildings, what kind of documents do you have? Do you have design documents? Of course you do when you're building something initially, but do you still have the documents that the building was built to, or the change to the system and the specifications and the submittals? Do you have all of those? We've done building evaluations over the years where you go to a building and they have no documents. So that makes things very interesting, how to test them and how to evaluate. Then you evaluate what's in the building. Again, we just talked about that. What's in the building, how are you supposed to be using it, so that it matches what the current facility requirements are. Then the last thing you do after you have the information is you create a project team. Who's going to be doing all of this work? Who's going to be doing various sections of the work? And that ends up in a existing building commissioning plan. Next. So level one, and these are generic for all systems, and mainly, as I've mentioned, we're talking about air conditioning, plumbing, and electrical. You can use this same process for roofs or security systems, windows, whatever. So the first thing you do is figuring out what you've got, or if you're hiring someone to do this, letting them walk the building and figuring out what's there. Then you make systems operational. If buildings have been turned off, turn them on. You'll find out that some things will run and some things will not. So that's the whole idea, is to figure out what is running. Is it doing what it's supposed to be doing what it was designed to do? Then, particularly lately, we want to be sure that we're talking about clean systems, talking about physically clean, or we're going to be talking about that in all three of the systems that we're covering here in this session. And as you go through, as you're checking things, you can make minor adjustments and repairs, things that have come loose, things that are not open, and things that have been changed. That's one of the issues from building operations standpoint. You have a minor problem, say an air conditioning or plumbing electrical system, and then somebody makes an adjustment that's supposed to be temporary that ends up being permanent. So the whole idea is to go back, make it work like it was supposed to. And the whole key to this is don't change a system until you try to make it work like it was supposed to the first time. Then from that, you develop a list. What do we want to do? What do we have to do? What are we trying to test? What are we trying to evaluate? So you make a list of that so you know that everybody on the team understands what you're supposed to be doing. Next. should do things are things that pretty much everybody would do on a startup, but you do functional and performance testing of equipment. There's actually 3 different levels of inspection or testing. There's the basic installation test, or is it there? And one way to understand that is to think of a light fixture. Installation, is it there? Functional, does it go on? Performance, does it do what it's supposed to, i.e. put light on the table? And that's true of plumbing, of air conditioning, of all of those. It's functional, performance, and testing. Then you compare that performance to the current facility requirements and what it's supposed to be doing. And then as part of that, you can provide and perform some more repairs. You basically do a commissioning or retro commissioning function where you're making things without spending a lot of money and a lot of time. You're making adjustments so that it's back functioning the way it's supposed to. Then from that, you can evaluate the operations and maintenance plans, programs. Are things being maintained the way they're supposed to be? If you have new personnel or a different organization doing the performance of and the training and the operations and the maintenance, we need to maybe train some people again. Then at the end of that, you end up with a list of, oh, I'd like to change that. I'd like to improve that, or we've got to improve that. Next. So from that standpoint, we go to level 3, which is might do. You review facilities, requirements. Again, look at the CFR, look at the testing and see what it's doing so that at this stage, because remember, different people may be doing each stage here. So if you're going to select the improvements and changes that you want to make, then you need to figure out, 1, can I afford them? 2, what is the time schedule? And are you going to modify existing systems? Or are you going to design and install new systems? All of those are various different options. Now, if you're either modifying or designing and installing new stuff, the key to that to make it work right is testing and commissioning. And we would all like to assume that all designs are perfect and everything that a contractor installs is perfect, but it's always great to have somebody that's independent and knowledgeable working for the building owner that verifies that all of that is in place. And then you develop and create, if it doesn't exist, a set of documents called systems manuals. And that's a new term for O&M manuals. Systems manuals contains an awful lot more than just an O&M manual. If you're interested in more information on that, get a hold of the ASHRAE guideline 1.4 for creating systems manuals. It has lists of things that you need and how to put them all together. The systems manual is the new requirement. It's now in the energy codes and the green codes as a requirement. And those are things that contain all of the systems designs, the submittals, all of the testing, the current facility requirements, and all of the training information. Then you update maintenance and planning and training, all of the things that you need to do. Trick there is to give the folks that are maintaining and operating the building a chance to operate the building the way it was designed. So that's what we need to tie the design and construction and training together. Next. Okay, let's go to air conditioning. Take a look at that. Turn on the system. Does it work? Doesn't it work? Does the air handlers work? If it's a VAV systems, do the zone boxes work? Do the thermostats work? Are the controls working? Does the energy management system work? What we often find in buildings, particularly the more complex buildings, that if they're older, more than 3 or 4 years old, the air handlers might go on, but the exhaust fans, say for the restrooms, maybe nobody paid attention to those and the belts are broke on some of those restroom exhaust fans. So the trick there is to physically test the area and the function of the equipment when you turn it on. Then you clean the system. That may mean hiring someone to do a physical wet clean of the coils. Then you check the filters. Are the filters dirty? Do those need to be changed? And we'll talk about improving filtration here in a little bit. But the cleaning might also include equipment casings, ductwork cleaning. So whatever dirt is in the air handler, on the coils, in the ductwork, is going to end up in the building, in the classrooms, in the gym. All of that dust is going to end up back in the breathing zone. Then you go through, after it's clean, and evaluate each zone. Temperature, humidity, is the airflow correct? Is the building pressurization between one zone or another, between the pressure and the outside? And what's the air quality? And all of those things are testable. Air quality is difficult to test, can also be expensive depending upon what kind of testing you're doing. We've been doing that for many years, and it's a very challenging function to test air quality. And there's been various systems that do that. There's some good equipment out there that does it, but on these things, you have to really carefully define exactly what you're testing. Because if you're testing, for example, on air quality, and you're testing for chemicals, and so on, we've been asked, okay, test for every chemical. Well, there's better than 100,000 different chemicals. Each one of them has a separate test. So you can't test for everything. It's not practical. Then the other important thing, once the thing is moving again, once it's doing its job, figuring out how much outside air you got. So that's one of the things that is important nowadays, to get fresh air in. And to be sure that all of the dampers and systems open and function. We find quite often buildings and systems that are more than a few years old, the dampers don't work anymore, or parts of them don't. Next. Then on level 2, your functional performance test plan, and then you perform testing and calibration. Again, adjusting whatever you can. Balance and repair functions, all of that is in, the basics. What we're trying to do here is make the systems work like they're supposed to, like they're originally designed to do. Now, the trick there is what they're performing to may not be what you want, what is currently needed. Again, back to the current facility requirements, what is needed now. Then you test the system interactions. There's more things that are connected together. And as what we find in new buildings particularly, and in old buildings, that air conditioning systems are now talking to the other systems. It used to be some 30 or 40 years ago or more that these systems sort of operated on their own. Now they're pretty much interconnected, and they talk to each other, or are supposed to be talking to each other. The problem you get to on construction is that each system is usually installed by a separate contractor. The contractors don't talk to each other. So the trick there is somebody has to be sure that something reacts. For example, when the fire alarm goes off, do the air handlers do what they're supposed to do? Does the smoke control system do what it's supposed to do? You have to look at the systems. Then you report all of that. And as part of that, you're finding things as you go through that you want to change, that you want to upgrade, that you say, oh, this is going to take some time and some effort. Next. So on level 3, take all of the stuff that you just learned and rebalancing and rechecking and figuring out what the potential is. What do we need to do? Do you evaluate current systems? Is it has enough size? Does it have the capability to upgrade? There are some systems that are really hard to change and to upgrade. Other ones are fairly simple. Some of the things you might evaluate, and this is probably one of the most important points when you're considering, not in the consideration of what you're doing for the building to upgrade it in the current situation for health and the rest of that. First, of course, is it working? Do you have air movement? Change filters to preferably MERV 13s, which are normally 4-inch filters, and you can't do that on all units. One of the important things there is, if you're upgrading the filters, the higher the MERV, the minimum efficiency reporting value, the higher the number, and those numbers go up to 16. MERV 13 is about an 85% efficient filter. The 2-inch MERV 8s are about 25%. So the MERV 13s catch smaller particles, but they're also higher pressure drop. So be careful when you're changing filters that the air handler will accept and has the capacity, both for the thickness of the filter and for the pressure drop. So if you put in too high a pressure drop on an air handler, you'll end up slowing the airflow down. If it's a direct expansion or a DX unit, you're going to end up freezing the coil and freezing the unit because you haven't got enough airflow going through because the filters are too thick or too high rated. Then you take a look at the outside airflow, and so you increase that and you check the controls, and there's a whole bunch of things that impact that. And the ASHRAE has a new document that just came out within the last couple weeks. It's about 41 pages long, but I highly recommend it. It's really got some good information about building starting and building operation. Covers all kinds of information about contaminants and filters and outside air. But the trick on the outside air is you can't just say, okay, we're going to change from 5% outside air to 30% on every unit. Well, sounds good, but the problem is outside air, particularly in hot and humid areas, have a lot of humidity. If you bring too much humidity into the building, you end up with mold and other problems. So part of the issue there, will the equipment heat and cool that amount of outside air? And that's going to take some calculations and some care. You want to bring in as much outside air as you can normally, but you have to be sure that the systems will handle that. The other systems, there's various other things that relate to that, but filtration, airflow, outside air are probably 3 of the things that you want to start with. Then if you want to add some things, you might want to talk to the folks with the ultraviolet lighting systems. Then that can be done. There's various different ways. UV systems have existed for many years. They've been used to control tuberculosis cells in medical areas. But the trick with a UV system, UV is basically sunlight. It has a certain frequency. Now they have systems you have to be careful with where you put the UV lights, because ultraviolet lights, if you put them where you can see the bulb, it will help kill all of the viruses and biologicals, but you will end up being blind and have skin cancer. So you don't want to be looking at a UV light bulb that's on. So that's part of the issue. We talked about tuberculosis and UVC systems. It takes about 24 hours for UV light to kill a tuberculosis cell. From the COVID virus and other viruses, it takes about 20 minutes at the right UV lighting frequency to kill that bacteria. So you can either put the UV in the air handlers. There's now some systems that are higher powered light that you can put in ductwork that will help a bunch. Or you can have a UV light system in the room. It's mounted high on up near the ceiling and puts UV lighting up near the ceiling, but it relies on room circulation in order to get the particles that you're trying to get rid of up into the UV light area. Then you have the next other system is various types of ionization systems. UV lights have been around for a long time. There's a lot of research data on it. One of the issues with ionization is that there is very limited, very limited peer-reviewed studies on ionization systems. So ASHRAE isn't comfortable with ionization. Not that it's a bad system, but there needs to be more research on it. So the point here, and there are other systems also, the point in all of these various systems, which I try to point out very strongly, is don't believe everything you read when you're reading about a particular kind of systems. Don't believe everything you hear. Do a lot of research, get some help, because every one of these suppliers that supplies any of these systems will say that their system's all you need, but that's not the case. Every one of these systems helps. Fresh air and filtration will help not only for the coronavirus, but help for all kinds of other things. So the whole idea is to have a comprehensive look, and then be careful with what you put in, and then operate it properly. Next. Let's look at plumbing. You wouldn't think plumbing would have any particular issues, but it does, particularly if you haven't used a facility for a while. One, you turn the systems on. If the water system's been off, turn it on, and then you flush all of it. Every pipe, every pipe that goes to anything that's going to have human contact. So you flush all of that. One of the reasons there is that most of your city water systems have chlorine and a few other chemicals in it to keep the bugs out, to keep it purified. Over time, if the water is not flowing, over time, that chlorine dissipates, and you end up with growth and biologicals and things in the water. So you have to get the chlorine back. So the trick there is you may have to have a plumbing company come in and actually inject chlorine chemical into the system, and then let it sit for 24 hours to purify the system, and then flush it again. So flushing the systems is very important. Then pressure and temperature control. Set the water heaters at 35 to 140 degrees, and you're saying, wait a minute, that's too hot for the faucet. That's right. The trick there is that Legionella bacteria, and Legionnaire's disease, which is Legionella bacteria, creates a very violent and virulent case of pneumonia, and can be fatal fairly quickly for some people. So the idea is that if you keep the temperature of the water high enough, then that kills, at 140 degrees, Legionella bacteria dies in a few minutes. At 100 to 110 degrees, it grows wonderfully. This is why cooling towers are a problem. So the whole idea there is set the storage hot enough to kill the Legionnaire's disease, and then use mixing valves to put it back where you need it at about 105 to 110 degrees for hand washing. Which brings up another issue that I didn't mention back in air conditioning, that what they found for viruses and and bacteria is that they're very sensitive to humidity. And at low humidity, and which is one of the reasons that the various flu systems and that flu comes up in the wintertime, because low humidity. Viruses and bacteria love low humidity. And they don't thrive well at 40% to 60%. So if you aim for 50% relative humidity in your building all year round, that minimizes what the bugs can grow and do. If they get too high humidity, like if you have too much outside air, then they tend also to grow more, and they tend to latch on to humidity particles and end up in places they shouldn't be. Now, getting back to plumbing, verify performance of the pumping and the storage systems. Be sure that they still all work right and the pressures are the same. And then before you let everybody back into the building, have somebody test the water quality, particularly on things that pipes that run the kitchens, that run the restrooms where people are washing their hands, the various water fountains and the rest of that. Have that piping tested to be sure that it's clean. Next. Okay, this is pretty much the normal that we were talking about in mechanical. Test it to be sure it works right, got the right pressures, temperature at all the location. If it's an operating system like a pump system and all the rest of that, you might want to commission it and do a retest and balance on it. Then you verify those results. What is it doing? What's the temperatures doing? What are the flows doing? Base that on to the CFR. What is it supposed to be doing at each location? And then if it is or isn't, then you put some options together, what you might want to change. You might want to change your hot water system. You might want to change locations of filters, all the rest of that. Next. So based on what you might do, as always, you have to evaluate and budget upgrades. And then you put in, install, and then commission whatever you put in from a testing and commissioning standpoint. And then you update the plumbing systems manuals and the training. So again, you can see what we're doing here is pretty much the same process for each one of the systems. Okay, let's go to electrical. Okay, in electrical, you probably want to activate, if that was things were turned off, probably weren't, but you can activate them, and then you test them. And the lighting, does it still go on? Have things changed? Has something fallen loose or whatever? And then you verify the controls, the light switches, the switches on the panels and the rest of that, and then check the programming. Over time, the programming for all of the control functions may have changed. The arc flash requirements, which are now part of the main panel requirements, may have been upgraded. Be sure all of that works. Then clean the light fixtures in this case. If you need, lighting, the dirty fixtures don't give you real good light. And if you clean the fixtures, then you can evaluate it with a light meter. Do you have enough light? And the Illuminating Society, IES, has requirements. And in fact, the energy code, the new energy 2018 energy code, IECC, has requirements for lighting that you might want to take a look at that are pretty practical. But if you're using old light fixtures like the MERV or like the 12 level lighting, they're not very efficient. So the trick there is you have lighting levels and you also have permitted energy levels for lighting. So all of that pretty much now is slanting towards the LED type fixtures. Next. Okay. One of the things that you should do, and several of these things are things you should be doing all the time anyway. You need to clean the panels and verify the connections. And what that's called from a process is called clean and torque. What you're doing there is cleaning the dirt out of the electrical panels. And you have to shut the system down to do this. Shut it down, clean the panels, vacuum it out, and then check the function and check the pressure that each wire and each connection, this isn't for every little small connection, but all of your panel connections, all of your main board connections, all of your main disconnects and that for mechanical systems and electrical systems should have the right connection torque that keeps you from generating hot spots, which can end up being dangerous to the building. Then once you get that all done, you turn the system on and you do an infrared test. So you have a certified infrared technician go around, open the panels, fully loaded, and then check the infrared image of that panel. That checks and locates hot spots, which means something is not tight or something is about to go out. The trick there is if you do an infrared test and you do the clean and torque, everything should be operating properly. If you don't, if you're going to have a failure on a switch or a failure on something and it's not connected right, not only can you have a failure, you can burn a building down. So infrared testing is not expensive. A lot of people do it once a year. Highly recommended to do it once a year. Clean and torque is probably every 3 years, but in any case, to get it done. Then you verify lighting requirements again. That's the same thing that we did on the plumbing and the air conditioning. Is it doing what it's supposed to do? And then you put a list of recommendations in for upgrades. Next. Okay, again, look at your budget, see what kind of funding we've got. And then if you're not converted to LED fixtures, to do that. Because they are much more efficient and you got better control of the lighting levels and better control of the light level, the light frequencies, so that you can get the whiter light or whatever level of light type you can get that's localized to that function. Evaluate the systems. In this case, you're looking at generators maybe, or load shed potential systems. Again, keeping in mind here that both for the LED fixtures and for upgrading systems and load shed systems, the utilities quite often have incentive programs. They will give you funding to make some of these upgrades. And if you're also saving money, saving efficiency, saving energy, there is a loan system that's not available in every area, but it is in Texas or most of Texas. It's called a PACE system, and it allows, basically what it does, it gives a loan to the facility, and this is mainly for private facilities and that, but there are limitations, and it's somewhat complex, but it allows the facility to get a loan at very low rates, and the loan is tied to the building so that the payment is made to the city or state or whoever's collecting taxes, so that the people doing the loan can count on the fact they're going to get repaid. Then after all of that is done, you can perform your testing and commissioning. You want to be sure that anything that's modified or updated or installed gets commissioned. And then again, update your systems manuals, train everybody. Okay, that covers those three systems. Let's go to the final slide. And I know Bill wanted me to put my picture on here so you know when I look at it, so thought I'd do that. So anybody have any questions?
If anyone has a question, please just go ahead and unmute yourself and ask away. This is
Look, I confused everybody totally.
I think it was a wealth of information, Jerry.
It just hit the high spots. There's a huge amount of information out there, and we're still looking at some of the systems. And there's a list, and that I think, Bill, I provided you a copy of. There's all kinds of websites, EPA websites, DOE websites, ASHRAE websites that have a wealth of information. You just need to know where that website is and what its address is.
Yes.
They've even got these websites in Europe. So the Europeans have done some interesting things. So there's a lot of resources, and ASHRAE has a page or two just of titles of standards that you might want to take a look at.
Absolutely. And Jerry, just to add to that for everyone on the call, on our website /Clean Slate, we have a whole slew of documentation, including that ASHRAE document that Jerry mentioned earlier, that 41-page document about building starting and some other items in there. It's a very thorough document, but it's on our website, buildingsolns.com/clean slate. And again, there's just a slew of information there. So I'm going to ask again, any questions for Jerry?
Yeah, Jerry, this is Gilbert Cruz over at Strike Desert in Houston. We are looking into a system called Casper Pro. Have you heard about it?
Which system was that?
It's called Casper Pro. It's spelled
I have. I think I've heard of the name. I'm not that familiar with it. That's a monitor system.
So this system is part of kind of what you were talking about. It has a UV and disinfecting device that goes inside the supply of our air handlers, and we're looking into investing in that. And I was just wondering if you have heard of it.
I haven't got any hard data on that. There are several systems for monitoring. You can monitor air handlers. You can monitor rooms with various different systems. But you have to sort of localize that to what your operation needs. But if you're installing things in air handlers, the trick there is dependent upon the size. Like many campuses have rooftop air handlers. They've got, you know, in building air handlers, you've got split systems. Every one of them is a little different as far as what it can do and what change you can make. Particularly with the room by room split systems, it's hard to get outside air without a custom unit. So there's some good things to get. My suggestion is to get as much data. If you want to send me some information through Bill or through just directly, my email is there. I can take a quick look at it and see what, and then give you some pluses and things to look for. So we'd be happy to do that. So I need to know a little bit more about what you're doing, what it's doing, and then I can react to it. Glad to help.
Thank you.
Thank you, Gilbert, for your question. Jerry, thank you very much for your time. This has been extremely educational. Next up, we have Valerie Shoup, but I just want to thank Jerry for being here, and thank you everybody for attending this particular session. And we are going to start Valerie's session in literally just about 6 or 7 minutes. So stay with us, and we'll be with you in just a few minutes. Thanks, Jerry.
Okay, thank you.